We're actually going to make the problems a little bit bigger today and see what will happen to the answer. So that's what we're going to do. We're going to make the problems just a hair bigger and see if our answer is going to, we'll be able to get the answer we need to get. So if I have, for example, x squared, the whole thing cubed. Remember, when something cubed, it means what? It is multiplied by itself. So this will be x squared times x squared times x squared. And what does x squared means?
X times itself.
X times x. There's the times. This one is x times x. There's the times. X times x. Now when you count how many x's do we have here, what do we have? 6 of them. So how do we get the 6? Do we add these numbers? Is 2 plus 3 equals 6?
No.
It's 2 times 3 equals 6. Yes. So that's another rule of exponents, which is power to a power. If you have a raised to the power of b, the whole thing to the power of c, that's equal to a raised to the power of b times c. You multiply the exponent. So when I have y to the 4th raised to the 3rd power, that's y to what power?
12.
12. 4 times 3, which is 12. X to the power of 10 to the power of 2.
20.
X to the power of 20. Let me have a little fun with it. Square root of x to the power of 8. We see stuff like this all the time, because I don't know what that means. Well, the square root of x means x to the power of 1/2. Raise it to the power of 8. 1/2 to the power of 8. You got to multiply the 1/2 times the 8. What is 1/2 times 8? This is 1/2. Let's multiply it by 8. It's 8 over 1. When you multiply fractions, the top times the top, which is what? 8 over 2, and that's a 4. So the answer to that is x to the 4th. You see a lot of problems like this, and because I don't know what the answer to that. A lot of times we tell people, when you see a square root of x, the best way to get rid of it in an equation is square both sides. Well, when you square this, what will happen to it? This becomes x to the 1/2 times the 2. What is 1/2 times 2?
1.
That's a 1. Which means x. So one way to get rid of the square root is by squaring it. When you square it, the square root will disappear, and that's the math behind it. Let's try a few more problems like these. Five to the second to the second. 5 to the 4th. And if this was a question on the homework, they probably want you to simplify that. When I say simplify, that means go to your calculator, do it by hand, and find the answer to that. 5 to the 4th is 5 times 5 times 5 times 5, 4 times. 625. Two to the negative 3 squared.
2 to the negative 6 over 1.
2 to the negative 6. Yes, you're going to make it over 1. That's fine. They don't like to see negative exponents. We mentioned that before, and I know what Jamie was saying, over 1. And the reason he said over 1, because last class we said when you have negative exponent, cross the line, change the sign. What does that mean? If you move it down, you cross that line, you'll change the sign of the exponent from negative to positive. So this becomes 1 over 2 to the 6. And now you have to go to your calculator and do what is what 2 to the, or do it by hand. What is 2 to the 6? 2 times 2 is 6 times. 2 times 2 is 4. Times 2 is 8. Times 2 is what? 16. 16 times 2 is what? 32. 32 times 2? 64. So it's 1 over 64. That's the answer that we're looking for. Negative p to the 4th, p, the whole thing raised to the 5th power.
Negative,
Notice the negative is sitting outside, so it's nothing to do with the 5th power here. It's sitting outside. And this is p to the 4th to the 5th. That'll be p to what power? 20. M to the power of 2 to the power of negative 1.
1 over m to the 2nd power.
Yep, this will be m to what? Negative 2. And when you have negative exponent, again, I'll put the rule down in case you forgot it. X to the negative n, the rule says 1 over x to the n. From last class.
And will they take that?
Huh? You know, you change it to 1 over m squared. Notice I'm only putting one thing inside the parentheses, only one thing. Now, let's try and make it bigger. Put 2 things, 3 things. I'm still going to apply the same rule here. As long as it's multiplication inside that. And the rule I'm going to be using, if I have x times y, and it could be anything x and y, raised to the nth power, this can be broken down to x to the n times y to the n. An example, 2y to the 4th. Notice that's a multiplication, that's 2 times y. I should be able to use this rule for that and make it 2 to the 4th times, because remember the power here is 1. 1 times 4 is 4. And y to what power? This is 1. 1 times 4 is 4. I'm still using the same rule. Power to power, you multiply. What is 2 to the 4th? Again, you're going to multiply the 2 4 times. 2 times 2. 4 times 2. 8 times 2. 16. Negative 3, a to the 2nd power. Notice the negative 3 inside the parentheses. Again, this can be written as negative 3 to what power? 2 times a to what power? 2. What's negative 3 squared?
Positive 9.
Positive 9 a squared. Negative, how about this one? Notice the difference between this and this is what? The minus sign is where? Outside. So the minus sign sits outside. right there. Let's look at the inside. This will be 3 to what power? Second times what? A to the second. Here's the minus sign sitting outside. What is 3 to the second? 9. A to the second. Let's make them a little bit bigger. I'm just growing with these problems. 2x to the 4th, the whole thing to the 5th power. If you got any question, just ask them.
2 to the 5th.
Good?
4 to the
Carl, 2 to the 5th times what? X.
X to the 20.
20. Excellent. Why? Well, Carl, this is the power. 1 times 5 is 5. 4 times 5 is 20. What should I do next now, Carl? Since you're on the right track with this one, there's one more thing I can do.
I have no clue.
Anyone? What?
5 and the 20?
Can't have the 5 and the 20, the different bases.
Multiply out the 2.
Absolutely. Take the 2 to the 5th and get the number for that. Get the answer 2 to the 5th. Don't leave it like this. So now, figure out what the answer to this one. What is 2 to the 5th? That's 2 times 2, how many times? 5 times. 2 times 2 is 4. Times 2 is 8. 8 times 2 is 16. 16 times 2 is
32.
32.
32x to the 20.
32x to the 20th. So don't leave it 2 to the 5th. They expect you to do that. P to the 3rd, Q to the 5th, the whole thing raised to the 3rd power. This will be P to what power?
9.
3 times 3, 9. Q to what power? 5 times 3, 15. Let me make them a little bit bigger, since you're doing good. There's negative 7, parentheses, m to the 5th, n to the 10, the whole thing squared. You want to give that a try, anyone?
7, negative 7 m to the 10th.
Negative 7, m to the 10th,
Times negative 7 n to the 20th.
Now, Jamie said times negative 7 n to the 20th. Let's see what, I'm not writing this. Let's see why. When you say negative 7 m to the 10th, I'll take that because you said power to power, you multiply. Well, the problem is the negative 7 is sitting outside the parentheses. It has nothing to do with the exponent here. So there's the negative 7. Let us sit outside. Let's do what's inside the parentheses. What is inside the parentheses? Right there. Let's do that. Power to power, what do? You multiply. So m to what power? 5 times 2? 10. And n to what power? 20. So the negative 7 is just sitting in the front there. You're not going to square that one. It's not this times this and this times that. That's only when you have addition between them. Now with multiplications. Yep. Let's try another one. Again, let's start making them bigger. 5, a to the minus 2. This is really important stuff for Algebra 2. So if you take an Algebra 2, you want to make sure you're very good at these rules. What do you notice here? That everything is raised to the power of negative 2. Everything. Before I start taking care of that negative 2, let me look inside the parentheses. What is the power of 5 as of now? 1. So let's apply the rule power to power. You multiply. So you will have 5 to what power? Negative 2, good. A to what power? Positive, positive 4, negative times a negative, that's positive. C to what power? Negative 8. Notice we have negative exponents. This is all over 1. Anything with negative exponent, if it's on the top, I'm going to take it to the bottom and change the exponent to positive. These two are going to move down. So what's left on the top? A to the 4th. That's this one. What is in the bottom now? 5 to the 2nd. I don't need the 1 anymore. C to what power? 8. 5 to the 2nd. C to the 8th. Now the next step is, what is the answer to this one? What is 5 squared?
25.
Good, 25, so that's A to the 4th over 25 C to the 8th. Let me try another one similar to this just to make sure. 7, A to the minus 1, C to the minus 3, the whole thing squared. Again, the power of 7 right now is what? 1 before we do anything to it? So this becomes 7 to what power?
2.
2. A to what power?
Negative 2.
And C to what power?
Negative 6.
Negative 6. Power to power. We multiply. All over the 1. Negative exponent. I see this one. It's going to come down. I see this one. It's going to come down. So notice the 7 has a positive exponent, stays on the top. This becomes what? A to what power? 2. C to what power? 6. And the last step again, don't leave the number 7 squared. What's 7 times 7?
49.
49 over A squared C to the 6. Good. Now, I didn't really do any fractions yet.
So don't.
So let's add them. Let's keep growing here. Today is all about growing. We're going to make the problem a little bit bigger. And the rule I'm going to use, if you have a fraction, x over y, just like the multiplication, to the nth power, you can make that x to the n over y to the n. That's the rule I'm going to be using now. It really doesn't change anything. Like similar to what we did before. So if I gave you this problem, x over 5 cubed. Still, power to power, we multiply. Before we look at it, before we start looking at the 3 there, look inside the parentheses here. What is the power of x as of now? 1. What about the 5? 1. So initially, again, these have a power of 1. Apply that rule now. X to what power? 1 times 3?
3.
5 to what power? 1 times 3, which is 3. And again, take this one and find the answer to it. 5 times 5 times 5. 5 times 5 is 25, times another 5 is 125. Negative a over b to the 4th power. This is negative a to the 4th over b to the 4th. The problem is that minus sign. So what do we do with the minus sign? Well, that's just, it's not an exponent there, Leonie. Leonie said bring it down, but it's not an exponent. So you don't bring it down. Only if you have negative exponent, you move it down. That's just a negative number. Well, the minus a is actually a minus 1. You're right. Minus 1 times a. That's what the minus a to the 4th. So this can be broken down to the minus 1 to the 4th power times a to the 4th. That's what the top is. This one to the 4th and this one to the 4th. And minus 1 to the 4th power is minus 1 times minus 1 times a minus 1 times a minus 1 4 times. Well, we know it's 1, 1, 1, 1. So when you multiply and the answer is 1, the question is it positive or negative?
Positive.
Why positive?
It's an even number.
Exactly. When that number is even, when you have an even number of negative sign, the result is always positive. When you have an odd number of negative signs, the result is always negative. So 4 is an even number. So the minus becomes a plus. So that's a 1. You don't need the 1 now. A to the 4th over b to the 4th. So minus 1 to n power is going to be plus 1 if n is even. It's going to equal to minus 1 if n is odd. If n is even, n is odd. Let me try another one. X to the 4th, y squared to the negative 2. Notice I'm spending a lot of time on this section, on these examples. I know how important they are.
X to the negative 8 over y to the negative 4.
X to the negative 8 over y to the negative 4. Very good, except, big problem, both exponents are negative. By what? Won't do it. You can change the exponent. Anytime you have a negative exponent, which says cross the line, change the sign, right? So if I take this one, and I bring it to the bottom, becomes what? X to the 8. And this is in the bottom. If I take it and move it up, cross the line, change the sign. So this will turn to what? Y to the 4th, when I bring it to the top, becomes a plus 4, and the bottom becomes what? X to the 8th. Again, with negative exponent, not negative numbers, negative exponents. I use cross the line, change the sign. When I say change the sign of the exponent. If the exponent negative on the top, bring it to the bottom, becomes a plus. If it's negative in the bottom, bring it up, becomes a plus. Let's try a couple more. Five over a to the negative 2.
5 to the negative 2.
5 to the negative 2.
Or a to the negative.
A to the negative 2. Again, negative exponent. Cross the line, change the sign.
A to the second over 5 to the
A to the second over 5 to the second. Good, but you're not done.
A to the second over 5 to the 20.
Excellent. A to the second over 25.
Wait for a catch.
There is no catch. That's it. These are the ugly ones, actually.
Said mines were easy.
Bless you. So what do we have? 4 to what power? Negative 1, u to what power? Negative 1, v to what power? Negative 1. Negative exponents, again, move them up and down. Down, down, up. That becomes what? V over 4 to the 1, which is what? 4. U to what power?
U.
U to the 1, just don't put the 1 if it's 1. And that's the answer. I'm trying to look in the back of the book for like the ugliest problem I can find. And I found this one. I found this problem. I don't think you get anything uglier than this when you take the quiz or the homework. So if you can do this, you're in good shape. Notice the minus sign is sitting outside, nothing to do with the 2. So let's make a fraction, put the minus sign in the front. And now let's look at that. Can we simplify this? 4 to what?
Second.
Second, good. A to what?
Positive 8.
Try again. Negative 8, good.
Okay.
What else?
B to the second.
B to the second, I'll take that. C to what?
4.
Negative 4, very good. And only the ones with negative exponents, move them up and down. This one comes down. This one goes up. Here's the minus in the front. 4 squared. And what are we going to have? What else with it?
C to the 4.
C to the 4th, good. And the bottom?
Second.
B to the second.
A to the 8th.
A to the 8th.
Solve for 4.
Yep, do the 4 squared.
16.
That's a 16. So there's the minus sign. 16, C to the 4th. I probably write A first, just alphabetical. A to the 8th, B to the 2nd. I was trying to look for the ugliest problem I can find in the back of the book, and that was it.
That's way easier than the lines, and you said that was easy.
One more thing left in this section, then we're done. Section 5.2. And that's scientific notation.
I have a question.
Yep.
When we're writing that out, do we put a space in between 16 and C, or is that like right
No,
next
there's,
to each other?
you can write 16c to the fourth, assume it's multiplications. Yep, it knows that. Now, let's take scientific notation. Sometimes you watch on TV and they go, Bill Gates still the richest man alive. He's worth $67 billion. And you go, what does that mean? $67 billion. Now you go, you know what? How many people live in the USA? About. We just passed the 300 million. So let's say about 310 million.
Really?
Yep, we're over 300 million. 310 million. I wrote this. Where's my eraser now? You're right, 310 million. I don't know if it's 310, but I know we passed the 300 million. So if we take his money and give it to all the people in the USA, how much each one of us will get? I don't think we have 310 million, but we'll put 310 million. Let's take that money he has and do it here. So ready for this? Here's my calculator. Can you see it on the screen? I want to make sure you can see that. 67, how many zeros? 9. 67, let's put 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8. I can't put the 9. Well, I did put the 9, but notice what happened to my number there. It went off the screen. Some of these calculators, you don't have a big space to write that 67 billion. Can you write that number on yours, Jamie? Or using an iPhone?
Yeah.
If you use the iPhone, you can put that number big. But if you have a basic calculator, sometimes these calculators don't have a big enough display to write that number. I might have another small calculator somewhere here, right here. If I try to use this one,
216
Yep.
bucks and 12 cents.
67 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9. I go hit the 9, I can't. The calculator is not big enough. We deal with large numbers all the time. We deal with the small numbers all the time. So if I can't do this problem on my calculator, that means I can't do the problem. So I need a way to take that number and write that in scientific notation. In scientific notation, we're going to take this number, notice, and there's no decimal to it. That means if there's a decimal point, or if you want to put a decimal point, where is it going to be? Your decimal point is right here. If the number does not have decimal, that's where the decimal point is. So to be able to use my cheap calculator here, I need to write this in scientific notation. What is that? Scientific notation says you can only have one non-zero digit to the left of the decimal point. One non-zero digit to the left of the decimal point. Well, if I look at this, I have more than one non-zero digit. I got a lot of digits to the left of the decimal point. If I move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. I stop here. Am I in scientific notation if I stop there? No. Why? Because you have two non-zero digits to the left of the decimal point. Two of them. Can only be one. So I got to move it one more spot, and that's right here. So that number becomes 6.7 times 10 to what power? How many places did we move it to the left? 10 to the power of 10. And I got to take this and divide it by, and let's take the 310 million people in the USA, 310 million. Again, my decimal point right now is here. I got to move it. How many places? Let's see. 1, 2, 3, 4, 5, 6, 7, 8 places. It's going to go right here. Has to be one digit. That's not a 0 to the left of the decimal point. That's 3.1 times 10 to the power of 8. And now you need to know how to use your calculator there. You can write this the way you see it, 6.7 times 10 to the power, but we never do it this way. We go, the first number, 6.7, and we have a button on the calculator called EE or EXP. So look for a button that's labeled as EE on your calculator, or EXP. Don't hit the times, just write 6.7, find that button. If it's in yellow, that means you have to hit the shift key or the second key. On my calculator, let me just find it. I don't know, I didn't see it yet. Where is it? I know, oh, I see it. I don't know if you can see it. It is in blue right over x to the minus 1. I see EE right there in blue. Right over that button. That means I have to hit the second key and push that. Notice how the calculator puts E? E here means 10 to the power. So I just got to write the power 10. To the machine, that's 6.7 times 10 to the 10. So look for EE or EXP on your calculator. Now I got to divide that, notice plenty of space now, by what? 3.1 EE, again, second, and the power of 8. If I do that, and it says Bill Gates can afford to give each one of us in the USA $216.13 before the money's gone. Again, I could have took this calculator here, clear. There we go. It should give me the same answer. 6.7, I gotta find the, this does not have EE, but it has EXP. Can you see the EXP in the bottom? I go EXP. It does a little bit different. It doesn't put E there, it just puts the little two numbers on the top. 10. That's 6.7 times 10 to the 10. Divided by 3.1, the power of 8, equals 216.13.
Damn.
Yep. So we can do any big number, any small number. If you're a science, taking science classes, you don't have to be a science major, almost if you're a science major, but if you are taking classes in science or technology, we do deal with big numbers. For example, the charge of electron, electricity, the charge of electron is this small. 6, 9, 12, 15, 18, 0, 1, 8. That's the charge. There's no way you can fit that calculator on that, that number on the small calculator. So now I got to move that decimal point how many places? I got to move it all the way to here. Actually, I don't have the last 0 here. 1,8, not 0,8. The charge of electron, 1,8. So I got to move my decimal point how many places? Let's see. 1, 2, 3. That's 3 of them. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I got to stop right here. This will be 1.8 times 10 to the power. Since this number is really small, it's always negative 19. Because remember, that's less than 1. It's a negative power. That's the number is more than 1. It's going bigger. That's positive exponent. So that's how you write that number. So on this calculator here, again, to write that number, I go 1.8 EE, and I just put negative 19. That's straightforward. That's 1.8 times 10 to the minus 19. On the small one, it's a little bit tricky. On the small one, I go 1.8 EXP. And I don't have that minus sign. Like the other one, you have that button for the to make it a negative number. This doesn't. So I gotta write 19, and there's a button that says plus minus, which means change the sign. See that plus minus right here? That's just change the sign of that. That becomes a negative 19. Each calculator is different. So you want to make sure whatever calculator you are using, you're familiar with these, so you can use it. You don't want to walk into the test going, how would I use my calculator? They won't tell you. You're on your own. So bring your calculator with you if you're using one, so we can show you how to use it. So that's really what scientific notation. Sometimes you get your answer and people say, look what I get for an answer. I go, what did you get? I got this number for an answer. 4.27, and it says E7. What does that mean? Notice that number is positive, 7. You got to move that decimal point how many places? 7 places to the right. They make it bigger. So that's 4.27. Let's move this. 1, 2, 3, 4, 5, 6, 7. That's how big that number. 427,000,000. That's what that number means. And I will stop here.